The code quiz questions are considered open book. This means reference materials such as the National Electrical Code, or NEC, can be used while answering the questions. However, these questions are not taken from actual National Electrical Code Master Electrician exams. They are created to provide practice and to assist in preparation for the real exam. The code quiz questions can be used as a study tool to help prepare for the actual exam. Understanding how to use the NEC is critical to passing electrical exams and performing safe electrical work. Navigating the NEC effectively involves several key skills. Firstly, familiarity with the NEC structure is essential. The NEC is organized into chapters, articles, and sections, each covering specific aspects of electrical installations. Understanding this hierarchy enables one to quickly locate relevant information. Secondly, proficiency in using the NEC index is important. The index serves as a roadmap to specific topics within the code. Being able to identify keywords and use them to find the relevant sections can save time and effort. Thirdly, the ability to interpret definitions is crucial. Article 100 contains definitions of terms used throughout the NEC. Understanding these definitions ensures consistent interpretation and application of the code requirements. Fourthly, understanding the use of tables and figures is required. The NEC contains numerous tables and figures that provide detailed specifications and requirements. Knowing how to read and interpret these visual aids is essential for compliance. Fifthly, cross-referencing is an important skill. The NEC often references other sections within the code. Being able to follow these cross-references ensures that all applicable requirements are considered. Sixthly, understanding mandatory and permissive rules is critical. The NEC uses specific wording to indicate mandatory requirements shall and permissive options shall be permitted. Distinguishing between these types of rules is essential for compliance. Seventhly, familiarity with common calculations is crucial. Electrical calculations, such as this for conductor sizing, overcurrent protection, and voltage drop, are integral to NEC compliance. Being able to perform these calculations accurately is essential for safe and effective electrical installations. Eighthly, awareness of regional and local amendments is necessary. Local jurisdictions may adopt amendments to the NEC to address specific needs or concerns. Staying informed about these amendments ensures compliance with local regulations. Ninthly, continuous learning and professional development is important. The NEC is updated every 3 years, and new technologies and practices emerge constantly. Staying current with the latest changes and advancements is essential for maintaining competency and ensuring code compliance. Tenthly, understanding the scope and purpose of the NEC is essential. The NEC is intended to provide practical safeguarding of persons and property from hazards arising from the use of electricity. Keeping this purpose in mind helps to ensure that the code is applied appropriately and effectively. Proper use of the NEC also involves understanding the different types of wiring methods permitted. These methods each have specific applications and limitations. Some of the common wiring methods include, firstly, rigid metal conduit or RMC, which is a heavy gauge threaded conduit suitable for use in harsh environments and for providing maximum physical protection to conductors. Secondly, intermediate metal conduit or IMC, which is a thinner walled threaded conduit similar to RMC but lighter in weight and generally less expensive. Thirdly, electrical metallic tubing or EMT, which is a thin walled and threaded conduit commonly used for concealed wiring in dry locations. Fourthly, flexible metal conduit or FMC, which is a flexible conduit used for connecting equipment that requires movement or vibration. Fifthly, liquid-tight flexible metal conduit or LFMC, which is a flexible conduit with a liquid-tight jacket used in wet locations or where flexibility is needed. Sixthly, non-metallic conduit or PVC, which is a rigid non-metallic conduit resistant to corrosion and suitable for underground or direct burial applications. Seventhly, electrical non-metallic tubing or ENT, which is a flexible non-metallic conduit commonly used for concealed wiring in dry locations. Eighthly, cable wiring methods, which include non-metallic sheath cable or NM cable, commonly known as Romex, used for residential wiring in dry locations. Ninthly, armored cable or AC cable, commonly known as BX, which has a flexible metallic sheath and is used for both exposed and concealed wiring. Tenthly, metal-clad cable or MC cable, which is similar to AC cable but with a continuous corrugated aluminum sheath providing greater protection. The selection of the appropriate wiring method depends on factors such as firstly, the environment, whether it's wet, dry, corrosive, etc. Secondly, the type of occupancy, whether it's residential, commercial, or industrial. Thirdly, the voltage and current requirements of the circuit. Fourthly, the degree of physical protection needed. Fifthly, local codes and regulations. In addition to understanding wiring methods, it is crucial to properly size conductors for electrical circuits. Conductor sizing is based on firstly, the ampacity of the conductor, which is the maximum current a conductor can carry continuously without exceeding its temperature rating. Secondly, the temperature rating of the terminals and equipment to which the conductor is connected. Thirdly, the ambient temperature in which the conductor is installed. Fourthly, voltage drop, which is the reduction in voltage along the length of the conductor. The NEC provides tables and guidelines for determining the appropriate conductor size for various applications. These tables take into account factors such as ampacity, temperature rating, and ambient temperature. Voltage drop is another important consideration in conductor sizing. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to a maximum of 3% for branch circuits and 5% for feeders. To calculate voltage drop, one must consider firstly the length of the conductor. Secondly, the current flowing through the conductor. Thirdly, the conductor's resistance per unit length. Fourthly, the voltage drop formula, which is voltage drop equals 2 times the length times the current times the resistance divided by 1000. Overcurrent protection is another critical aspect of electrical safety and NEC compliance. Overcurrent protection devices, such as fuses and circuit breakers, are designed to protect conductors and equipment from overloads and short circuits. The NEC specifies the maximum overcurrent protection for various types of conductors and equipment. The selection of the appropriate overcurrent protection device depends on firstly, the ampacity of the conductor being protected. Secondly, the type of equipment being protected. Thirdly, the interrupting rating of the overcurrent protection device. The interrupting rating is the maximum fault current that the device can safely interrupt. It is essential to select a device with an interrupting rating sufficient to handle the available fault current at the point of installation. Grounding and bonding are essential for electrical safety. Grounding provides a low impedance path for fault current to return to the source, tripping the overcurrent protection device and energizing the circuit. Bonding ensures that all metal parts of an electrical system are electrically connected, minimizing the risk of electric shock. The NEC specifies the requirements for grounding and bonding in Article 250. These requirements cover firstly grounding electrodes. Secondly, grounding conductors. Thirdly, bonding jumpers. Fourthly, equipment grounding. Grounding electrodes are used to establish a connection to the earth. Common types of grounding electrodes include metal underground water pipes, ground rods, and ground plates. Grounding conductors connect the grounding electrode to the electrical system. Bonding jumpers are used to connect metal parts of the electrical system together. Equipment grounding ensures that metal enclosures and equipment frames are grounded, minimizing the risk of electric shock. Another key area covered by the NEC is wiring and hazardous locations. Hazardous locations are areas where flammable gases, vapors, liquids, dust, or fibers may be present, creating a risk of fire or explosion. The NEC classifies hazardous locations into different classes, divisions, and groups based on the type and nature of the hazard. Each classification has specific requirements for wiring and equipment to minimize the risk of ignition. The requirements for hazardous locations cover firstly, the type of wiring method permitted. Secondly, the type of equipment permitted. Thirdly, the sealing requirements. Fourthly, the bonding requirements. Wiring methods permitted in hazardous locations typically include rigid metal conduit, intermediate metal conduit, and cable with a gas-tight or dust-tight jacket. Equipment permitted in hazardous locations must be specifically designed and certified for use in the particular class, division, and group. Sealing is required to prevent the migration of flammable gases, vapors, liquids, dust, or fibers from one area to another. Bonding is required to minimize the risk of static discharge, which could ignite flammable materials. The National Electrical Code also addresses wiring for specific types of equipment. The NEC provides detailed requirements for the installation of various types of equipment, including firstly, motors, secondly, transformers, thirdly, generators, fourthly, lighting fixtures, fifthly, appliances. The requirements for equipment wiring cover firstly, the conductor sizing, secondly, the overcurrent protection, thirdly, the grounding and bonding, fourthly, the disconnecting means. Conductor sizing for equipment is based on the equipment's ampacity rating. Overcurrent protection is provided to protect the equipment from overloads and short circuits. Grounding and bonding are required to minimize the risk of electric shock. A disconnecting means is required to allow the equipment to be safely de-energized for maintenance or repair. In addition to the technical requirements, the NEC also contains administrative requirements. The administrative requirements cover firstly, permits, secondly, inspections, thirdly, plan reviews, fourthly, code enforcement. Permits are typically required for electrical installations to ensure that the work is performed in accordance with the NEC. Inspections are conducted by electrical inspectors to verify that the installation meets the code requirement. Plan reviews may be required for larger or more complex projects to ensure that the design complies with the NEC. Code enforcement is the process of ensuring that the NEC is enforced and that violations are corrected. Staying current with the latest edition of the NEC is essential for all electrical professionals. The NEC is updated every 3 years, and each new edition contains revisions and additions to address new technologies, changing practices, and emerging safety concerns. The process for developing and revising the NEC involves a consensus-based approach, with input from a wide range of stakeholders, including electrical contractors, engineers, manufacturers, inspectors, and safety experts. The NEC is developed and maintained by the National Fire Protection Association, or NFPA. The NFPA standards making process is open and transparent, allowing interested parties to participate in the development of the code. To stay current with the latest edition of the NEC, electrical professionals should firstly purchase a copy of the latest edition of the NEC. Secondly, attend training courses and seminars on the NEC. Thirdly, read industry publications and articles about the NEC. Fourthly, participate in local code discussions and meetings. By staying current with the NEC, electrical professionals can ensure that they are performing safe and compliant electrical installations.